Okay, good morning, everybody, and welcome. So today we're going to be continuing on with chapter 5, and right now we are lesson number. So, what we're going to do, let's just go ahead with this one here. Use the following tips to solve logarithmic equation. So, isolate logarithms to one side of the equation, combine several terms with logarithm into a single logarithm. Once you have combined um, all logarithm terms into one logarithm, convert into exponential form, and then solve for variable. Remember to check for extraneous roots. So let's go ahead and do that one right now. Um, okay. What I'm going to do is I'm going to do that on a separate sheet of paper so that I can show all of the work and also the checking, because I find that we didn't have enough room in here for us to show all of our work. So let's do example 1. So this is so let's start with letter A. It says here log of x base 4 plus log of x plus 6 base 4 is equals to 2. Now, these things, all the things that we've done so far in terms of logarithm rules or laws of logarithm, we will be using that here. So in this particular case, log of x base 4 plus log of x plus 6 base 4 is equals to 2. So using the laws of logarithm, because these two logarithm base 4 are added, we can rewrite that as log of x times x plus 6. And again, that's operating base 4 equals to 2. So this one is using logarithm law. Log of m plus log of n is equals to log of m times n. So this is where we are, and then we're changing it to that. So now that we have that part, so that's the explanation for these step. The next part is, now, what does this really mean? Log is figuring out is basically the exponent. So what this is saying is that 4 to the exponent 2, 4 to the exponent 2 is equals to x times x plus 6. So it's going to be, let's rewrite that as exponential form. So from here, we used rewrite log form to exponential form. So we did that one. Now that we have this part, when you look at this part, 4 squared, we know that's 16. So we're going to put 16 there is equals to x times x plus 6. Now we're getting to a quadratic formula, a quadratic equation rather. So it becomes 16 equals to x times x squared, x times 6 is 6x. So from here, we have created a quadratic equation. Now that it's in a quadratic equation, uh, this is something that we've already learned way back in grade 10, is to how to solve for a quadratic equation, also grade 11. Um, so we're gonna bring this 16 to the other side of the equation, so it becomes this x squared plus 6x minus 16. And because this is a quadratic equation, we can solve by factoring. Solve quadratic equation by factoring. Um, I, the reason why I'm solving is by factoring is because I know that this is a factorable um, trinomial. So we can factor that. So, and that factors to x plus 8 and then x minus 2. X plus 8, x times x minus 2. And then once we have it here, we can use the zero product property to solve for x. So you have two solutions in here. So you can have x plus 8 equals to 0. So x is equals to negative 8. And then the other one is x minus 2 equals to 0. So x is equals to 2. So it looks like we might be having two solutions. So it looks like we have two solutions in here, but let's see if we could actually have two solutions. Now, here's what we can do. We can check our solution. So here we can check our solutions. Okay, what we're trying to find out is that which one of are both solutions the right solution, or is there an extraneous solution? So let's take a look. Log of base 4. So what we're going to do is we're going to check x is equals to negative 8. Okay. Okay. So now that I've got to this part in here, let me see if this is gonna help us figure it out. Remember, logarithm is looking for an exponent. So logarithm of base 4 of negative 8. So we're asking, is there an exponent for positive 4? Is there an exponent that I can apply to 4 that will give me a negative 8 result? And then the answer would be no. So this one here has no solution in this case. So in this particular case, the question is, ask ourselves, ask ourselves, ask ourselves, is there an exponent that I can apply to 4 to get negative 8? And the answer there is no. Okay, So the answer is no. So therefore x equals to -8 is not a solution. Okay. So let's take a look at this one in here. Now what about, can we check for x equals to 2? So check. Now let's check for x equals to +2. Okay, so let's see. Of log of base 4 of 2 plus log of 2 plus 6 is equals to 2. So what we can do is we can simplify that. So we can say log of 2 base 4 plus log of 8 base 4 equals to 2. So what we're going to do is we're going to just work this out. We know that the right side is going to be always 2. So let's see if this one's going to give us 2 on this side as well. Log of 2 base 4 plus log of 8 base 4, we can combine those two to make it look like this. Log of 2 times 8 base 4, and that becomes log of 16 base 4. And we look at this one here. Let's see if we can answer this. What exponent do I apply to 4 to get 16? So 4 to the exponent of something will give me 16. The answer would be 2, because 4 squared is 2. So the left side of the equation is equals to 2. The right side of the equation is also equals to 2. So this is the correct solution. So therefore, the only solution is x equals to 2. Okay? So that's that. Now we're going to move on to example B. Example B. Okay, so this one here, there's no base indicated, so it's understood this is operating in base 10. So let's go ahead and take a look at this one now. If you have any question at any point, just let me know. Okay. I'm just going to take a look over here, and then in case somebody has asked me a question on my email. Okay, so no questions on my email. So let's just go ahead and do this one here. Log of x base 10 and log of x plus 3 is equals to 1. So what we're going to do is we can rewrite this so that we have a single logarithm. So single logarithm. So apply logarithm rules. So this becomes log of x times x plus 3, x times x plus 3, and then that's equals to 1. So now, so write as a single logarithm, which we did. And then we're gonna rewrite that, change from log form to exponential form. Okay, so that means this is base 10. So 10 to the exponent 1 is equals to x times x plus 3. And then we can say, okay, 10 to the 1 is 10 x times x plus 3. And then again, we are creating a quadratic equation in here. So 10x times x will give us x squared. X times 3 will give us 3x. And then put the 10 to the other side of the equation. And then looking at this trinomial here, this is a factorable trinomial, so we can rewrite that as in a factored form. So it's x plus 5, x minus 2. Okay, so it's very similar to what we've seen in example number 1. And then we're going to use a zero product property. So that means we have two possible solutions. So, but we'll have to check. And then this one here is x minus 2 equals to 0. So x equals to 2. So that part. So it looks like we might have two solutions, but let's see. When you look at this one in here, check. We're going to check x equals to negative 5 first. So log of negative 5 base 10 plus log of negative 5 plus 3 base 10 equals to 1. So one side, the right side is 1. And then let's just take a look at this one here. So let's ask ourselves here, 10 to what exponent will give us a negative 5? 10 to any exponent will actually won't have a negative 5 answer. So this one here, x equals to negative 5 is an extraneous solution, okay, because 10 to any exponent will not give us negative 5. Now let's check x equals to, 2. Check x equals to 2. So log of 2 base 10 plus log of 2 plus 3. Of course, that's base 10 equals to 1. Okay, so we can simplify that to log of 2 base 10 plus log of 5. Okay, so we are doing the left side of the equation, and then the right side of the equation. The right side will always be 1, so we have to take a look and see if we can make this equal to 1 as well. So sum of logarithm, we can rewrite that as log of 2 times 5. So this is 2 times 5 base 10. I don't have to write down the base 10 there because it's understood it's 10. So log of 10. So log of 10, that means 10 to what exponent? Okay, just going to write down the 10 here. So this means 10 to what exponent? That will give me 10. So the answer is 1. So this one, the left side gave me 1. The right side is 1. So left side and right side are equal to each other. So therefore, the solution is x equals to 1. Okay, so as you can see, a lot of these things that we've talked about in terms of changing from logarithm form to exponential form, applying the laws of logarithm, and all the things that we know about solving equations are being explored in here, being part of our um, solving this logarithm equation. Okay, so if you have any questions about letter B, um, example 1, letter B, um, just don't hesitate to, and if you're watching this live stream, just write that on our live chat if you have any questions. Okay, so we did example number 1, letter A and letter B. So we're going to go to example C. Okay, so just remove this. So this is what we are doing right now. So this is everything is on page 22. Oh, as you can see here, we have 2 logarithm on each side of the equation. So let's just see how this one's gonna play out. Okay, so this is really interesting. So how can we go about this one here? Now you see here, these 2 logarithms. Oh, I forgot to put log. There you go, much better. So log of x base 2 plus log of x minus 2 base 2 is equals to log of 9 minus 2x base 2. So what are we going to do here? Let's see. These 2 are added. Okay, we're going to apply the laws of logarithm to make this a single logarithm. So this one could be, because it's added, it's the same thing as log of x times x minus 2 base 2. And then I'm just going to just write that log of 9 minus 2x base 2. Okay, so that part. What does that mean? So they are both base 2. Right? So if these are both the logarithm using the same base and they're equal to each other, so therefore x times x minus 2, x times x minus 2 is equals to 9 minus 2x. So can you see here they have the same base? Now, if these two are the same and the overall they're equal, so that means x times x minus 2 must be equal to 9 minus 2x. Okay, so we could, yeah, I'm just thinking, oh, yeah, I'll just go like that. Okay. So these two have to be the same. And I'm actually also thinking about a different strategy. That's why I'm kind of pausing for a little bit. Just thought about it, a different strategy, but I'll continue on with this. So this one here, we can expand this. So x squared minus 2x equals to 9 minus 2x. This brings us over there. So that becomes x squared minus 2x. If I bring everything to one side, because I can see that I'm going to have a quadratic equation in here. So negative 2x and positive 2x cancel each other out. So we're left with x squared minus 9 equals to 0. So this is called the difference of squares. We can factor that out certainly. So this is x plus 3, x minus 3. So we have two possible answers. X is equals to negative 3, and then x is equals to positive 3. Okay, but again, if I put negative 3 over here, okay, we're going to run into um, an error, some kind of an error, because 2 to the exponent, 2 to what exponent do I need to get a negative 3 for x? And there's no solution. So this part here, this x equals to negative 3 is an extraneous solution. Okay, so therefore the only solution, okay, let's check the other one. Log 2 times 3. Okay, so this becomes log of 3 base 2 plus this is going to be log of 1. If I simplify this, log of 3. Now let's take a look. Um, now this part in here, this is going to be interesting. 2 to what exponent will give me 1? The answer there is 0. Okay, because what exponent do I need for 2 to get me an answer of 1? Okay, so the exponent is 0. So this is log of 3 base 2. So we're going to have log of 3 base 2 is equals to log of 3 base 2. So they're the same. The left side is equal to the right side. So they're the correct answer. Okay. So therefore, the solution is x equals to 3. X equals to 3. Good. So we've done example 1, A, B, and C. If you have any questions, feel free to ask. Okay. So those ones are very, very interesting. Now let's take a look at letter D, E, and F. Those are the last 3 examples that we have. Okay, so letter D. Example 1, letter D. Log of x squared minus 9 base 8 minus log of x plus 3 base 8 is equals to 2. Okay. Okay. I just got an email. Here. Okay. So I just heard that a student is trying to get into our video, but there's something going on with, I think, at the YouTube end, and they couldn't get into the video. So, and then they said that there's no audio. So I'm just gonna continue working with this, and if you have, and when I posted it again, then you can watch it. Okay. So let's take a look at this one. This one in here, we can, because this is subtracted. Okay, so we're gonna use log of m minus log of n is equals to log of m divided by n. So if log of m minus log of n, we can rewrite that as a single logarithm m divided by n. So that's for that piece. Log of x squared minus 9 divided by x plus 3. And this is base 8 equals to 2. Okay. So what can we do with this one in here? So we can rewrite that as right as exponential form. So we're going to write this as an exponential form. It means 8 squared. 8 squared is equals to x squared minus 9 divided by x plus 3. Okay, so we can simplify that. So this is 64 equals to x squared minus 9 divided by x plus 3. So that we can say x plus 3, x minus 3. So if we factor this out, we can cancel out the x plus 3 factor. So that's gone, that's gone. So we can say that 64 is equals to x minus 3. So that means bring this to the other side of the equation. So 64 plus 3 equals to x. So x equals to 67. So x is equals to 7. Okay, now let's see if that one. Let's do checking. X equals to 67. So it's going to be log of 67 squared minus 9 base 8 minus log of 67 plus 3 base 8. That's equals to 2. Simplify that. So log of, this is going to be a big number. So that's going to be 67 squared minus 9. It's 4,480 base 8 minus log of 70 base 8. Now the right side is going to be always 2. So let's just simplify this part in here. Okay, we got a left side of the equation, and then the right side of the equation is always 2. Because these logarithm are subtracted, we can rewrite that a single logarithm means log of 4,480 divided by 70 base 8. And then that becomes log of 64 base 8. And then now you'll probably see, okay, well, that makes sense, because what exponent do I need to apply to 8 to get me 64? The answer is 2. So the answer is 2, and that was correct. So therefore, the solution is x equals to 67. Okay. Okay. Okay, now let's take a look at example letter E. Okay. let's see here. 2 times log of x base 2 minus log of x minus 1 base 2 equals to 2. So I'm just going to write that down. 2 log of x base 2 minus log of x minus 1 base 2 equals to 2. Okay, that's really nice. Again, we're going to use the law of logarithm in here. Okay, we're going to use the laws of logarithm. So this part in here, before multiplying it in, okay, I'm going to have the laws of logarithm. Use log law for this part in here. Okay, so that's log of m to the n is the same thing as n times log of m. So can you see here the n? The n would be the 2 log of x. Okay, so this exponent n will be, we're going to be putting it right there, applying it to the m. So in this particular case, we're going to put that right there. So this becomes log of x squared base 2 minus log of x minus 1 base 2 equals to 2. Okay, and then this one here, subtraction. So we're going to use this log of m minus log of n is equals to log of m divided by n. So we're using this one to simplify this. Okay, so that becomes log of x squared over x minus 1 equals to 2, and that's base 2. Okay, so now that it's single logarithm, we can write that as an exponential form. So now write as exponential form. Let's see what that looks like. It means 2 squared, 2 to what exponent? So 2 squared will give me x squared divided by x minus 1. So 2 squared, so that this base 2 is this 2, and then this exponent 2 would be this one, is equals to x squared over x minus 1. And then from here, we can cross multiply, right? So it's going to be 4 equals to x squared over x minus 1. Cross multiply here. So this one cross multiply there. So it's 4 times x minus 1 equals to x squared. And then expand that. So 4x minus 4 equals to x squared. And put everything on one side of the equation. This becomes 0 equals to x squared minus 4x plus 4. Okay, so this one here is factorable. It's going to be x minus 2 times x minus 2. So therefore x is equals to positive 2. Positive 2. Okay. Good. So that's example 1E. Example 1E. Now let's take a look at the last example, example F. So all of these notes will be posted on our blog later on, very, very shortly. So if you didn't catch it, you'll see it. So this is now page 23. Example 1, letter F. Natural log of x plus 1 minus 2 equals to 0. This is interesting. Okay. Now, because this is the natural log, the base here is base e. Okay, so we are this we are using base e for natural log. So let's see if this one could be simplified. Oh, I can put this over here. So natural log of x plus 1 equals to positive 2. So what does that mean? It means that, okay, so it means we can rewrite that. We can write as exponential form. So this is base e. So that means e to what exponent squared to get us x plus 1. Okay, so now, so solving for x, we put the 1 to the other side, so e squared minus 1 equals 2x. So remember, e is just a number, right? E is just a number. It's approximately 2.7 something. 2.718. Okay, so when we see an e, it really means it's about 2.718. So let's see if we could check it. So let's check. Okay, so let's check our solution. Natural log of e, okay, x here. We said x is e squared minus 1, e squared minus 1 plus 1. So remember, this is the x, and then plus 1 minus 2 equals to 0. So the left side of our equation is all of these, and then the right side of our equation is just 0. Okay, so if we could prove that this is 0, then our solution is correct. So let's see here. Natural log, we can simplify this, e squared minus 1 plus 1. So that's e squared minus 2. And then remember, this is operating in the e. So e to what exponent will give me e squared? So the answer is 2. Okay, so e, what exponent do I need to apply to e to get an e squared? So the answer is 2 minus 2. So that's equal to 0. So 0 is equals to 0, which is our correct answer. So therefore, x is equals to e squared minus 1. And is the solution. There you have it. This is a really a big topic, and certainly is a lot of background information that we have to apply here that we've learned at the beginning of the booklet or the chapter. So make sure you're keeping up with the work. So that's the end of the lesson for today. I'm going to ask you to keep on working on the practice questions. So practice questions, these are your practice questions for you to work on. And if you have any questions, feel free to contact me. And I've also set up a Google Meet for our classroom. So um, that's another way of communicating with me. And yeah, um, so you can certainly try those questions. And if you have any problems with them, just let me know. Okay. So thank you very much for watching, and I will be posting this video very shortly so that um, if you had problems earlier, you could see it again. Okay. So in the meantime, I'm gonna leave that with you, and yeah, have a good day. Thanks for watching.